Hi everyone, welcome to the fifth lesson for topic 4.5 energy, work and power. So this is also the last lesson for M1. So after this lesson, then you can start the revision for the whole complete syllabus for M1 already. Okay, so yeah, let's look at the learning outcome of today. So in the previous lesson, we have discussed about the energy and also the work. So for the last lesson, we are going to look at the part for power. Okay, so we will understand what is that meant by power, what's the definition, and what's the relationship between power, force, and velocity. So that's the first part. Then after that, when we understand power, then we are going to use it to solve some problems. So some of the problems that you will see will be involving the part where we have instantaneous acceleration of a car. Okay, so yeah, basically it's about the definition of power law. This is like one of the example of the questions that you will see, and they try to put it inside the learning outcome as well. Okay, so now let's start with the introduction. Okay, let's start with the introduction. So energy can be put into a system by an engine. Okay, so what is this engine doing is that the engine helps to convert the fuel, which is from the terms of chemical energy, and it converts it to a driving force. So this is how our vehicle move, right? So for example, when you drive a car, then it must be the petrol in the car. Then the engine helps to convert the petrol, which from the chemical energy into so-called a kinetic energy, so that the car can move. Okay, so since that the car or the engine can produce a certain driving force, right, then we can find out the work done by the engine by using our normal equation, which is the work done is equal to the force multiply the distance that the vehicle actually travel. So the F here means the driving force. Then after that, the D is our distance. Okay, so now let's look at these two situations. So you can imagine that there are two types of car. So we try to assume that the car actually have the same mass. Okay, so the car travel for 500 meter each, and then their initial velocity and the final velocity is actually the same. Okay, if let's say we try to find out what is the total work done that created in this journey. So we normally find total work done by using FD, right? So in this case, we do not have the driving force, but we have the initial and the final velocity. Then we know that total work done is actually equal to the change in the kinetic energy as well. Okay, so let's try to look at it from there. So we have half. So since the mass is constant, right, then we have v squared minus u squared, and you realize that the u squared and the v square in this situation is actually the same. So what can we see from this situation is that it will always take the same amount of work to make a car speed up from 0 meter per second to 25 meter per second. Then you say that if let's say they take the same amount of work, then what's the difference between two cars? So for today's lesson, that's the part that we are going to discuss. So which means that we are going to compare them in terms of the power rather than the work. So a more powerful engine will get the car to 25 meter per second. I'm sorry for the mistake here. I'll try to change it in the handout. Okay, so we'll get the car to reach 25 meter per second much more quickly than a less powerful one. So which means that instead of like looking at the total work done, which get it by the force multiplied by the distance, we are now looking at what is the time that actually used by this vehicle to achieve this amount of work. Okay, so that's the idea. So the definition of power is the rate of the engine doing work. Okay, so how do we find the average power generated by an engine? The average power is actually given by total work done by the energy, right? And then divide by the time taken for the engine to do the work. Okay, so when we write in short form, then it will be the average power is actually equal to the work done divided by the time. So, and we also know that work is actually equal to force multiplied the distance over t. Okay, so this is our formula here. Okay, so something interesting about this formula is I want you to be aware of, we are talking about average power here. So that's why when you try to look at this term, right, then normally we know that we can try to write it in the form of F then d over t. So what is distance over time? That's basically our velocity, am I right? So my question is, can you actually use FV rather than FD over T? So the problem is depends on the situation. Okay, so the first idea is that if let's say you are trying to use this in this situation, then you have a problem. Are you going to use the V over here or you are trying to use the V over here? And if let's say you are trying to use either of them, is that represented the average power? So the answer is no, because you'll realize that at different instant, they will have different power. So that's why when we talk about average power, we are looking at the situation as if like the whole journey, you are having a average power. So which means in another words, if you want to use the formula of FV, you must make sure that either your V is a constant throughout the whole journey. So which means that for the starting and the end, the velocity is constant. The other thing is that your F is given, sorry, your V is given an average number. So which means in this case, then you have, I mean, they try to find out the total distance, then divide by the total time, then you have the average velocity. Then you can try to use this. So other than that, if let's say your velocity is not an average one, you wouldn't be able to use it to get your average power. Okay, I hope that you can get the idea. Okay, so now let's move on to the second part. So this is the part for us to find the average power. But how are we going to find the instantaneous power? Okay, so it's the same thing now. So we know that power is found by using F times D over T. So in this case, we are talking about a short interval of time. So meaning the time is having a very small change. So if you can recall from what you learned in P3, so we know that the small change of D with respect to T. Am I right? So we are talking about the driving force is constant. Then after that, the delta T over delta T is like the small change of the distance with respect to small change of time. So when we have the small change of D over T, right, we can always write it in dd over dt. So what is dd over dt? It's like the rate of change of distance with respect to time, right? So this is how we get FV. So I'm discussing different thing out. So this one is for instantaneous power. So we can straight away use FD in this case. Okay, so something important to note is that you must make sure that the F that we are discussing here is the driving force, not the net force. Okay, so do not be confused later when we are trying to combine the question together and you need to solve like the Newton's second law of motion, then because there's a part that you will use F equals to ma as well. The F there and the F here is different because when you try to look at this situation, right, the F that we are talking about here is the driving force. What is the work done by the engine? So it's the driving force multiply the distance. It is not the net force. So sometimes if let's say we do not want to confuse yourself, then sometimes they will try to use a big D instead of using the F here. So which means that you can always remember as well P is equals to dV instead of like FV. So you have an idea that you should use a driving force, not the net force. Okay, and normally in all the questions that we are going to look at later is about car. So that's why it's all about driving force that we can try to just change it to D instead. Okay, so now what is the unit for power? So we know that power is work divided by the time, right? So in this case, we have the work, which is joules. Okay, then after that, the time is seconds, so joule per second. So joule second -1. Okay, or normally we don't really write like joule per second. We try to write it watts. Okay, and that's denoted by W. Okay, and when you do some of the question, you'll realize that instead of writing in watt, then we'll always write in kilowatts as well. So it's like 1,000 watts, so it's kW. Okay, because normally the number is like a bit, I mean, it's like quite a big number. So that's why we will try to change it to kW. So the answer isn't looks like very long or having quite a number of zero there. Okay, so the last one, power is also a scalar quantity. Okay, so now let's try to look at the first example. Then after that, we'll move on to further notes that I try to explain it. What happened if let's say we have a constant power, then we explain further on the instantaneous power here. Okay, let's look at example one. Okay, a car of mass 1,500 kilogram is being driven along a level road. So that's like the road, then the car. Okay, so is yeah, then the mass of the car is 1,500. So this car accelerates from 0 km per hour until 100 km per hour. So the U is 0. So yeah, please be noted that the unit here is km per hour. So later we are going to change it as well. So 100 km per hour in 10 seconds. Okay, so the air resistance and friction can be ignored. So the question wants to find out the average power generated by the engine. Okay, so we know that if let's say we need to find the power, we need to find the work done, then divide by the time. So for the work done in this case, then we need the driving force and also the distance, right? So in this case, we are not given the distance and we are not given the driving force, and that's nowhere that we can try to find it out, but we are given the initial velocity and the final velocity. So in this case, we need to use the work energy principle that we have learned previously. So the total work done here is equal to the change in kinetic energy, which is half. Then the mass here is 1500. So V square minus U square, remember to change our unit here. So 100 km change to meter, then the hour change it to second. So it's divided by 60 times 60. Okay, square. And then for this one, it's 0. After you convert, it's still going to be 0 as well, right? So now let's try to expand it. So we have 750. So at this part, then I guess we are going to get 1, 2, 1, 2, 3 divided by 360. Okay, so you should be able to get 2500 over 9 square. Okay, so when we solve that, then we can get our W is equal to 578,703.70. Yeah, I'm just going to copy down everything. Okay, so after we get this, then now the question wants to find out the general average power, right? So that's why we have this total work done already. Then we can find out our average power. So the average power is equal to the work done and then divide by the time, which is 10 seconds. Okay, so we are going to get an answer for 57870. Yeah, it's just one place to the front. Okay, so this is why I say that normally for your power, you will get quite a big number. So that's why you have an option. Depends on you. When you try to answer in watts, it doesn't matter as well. And you try to answer in kilowatt, it doesn't matter as well. So if you are interested to change it, then you can always change it to three significant figure. So in this case, then it's either you can answer 57870 watts, or in the other case, if you want to answer in kilowatts, then it will be 57.9 kilowatts in 3SF. Okay, so yeah, that's the idea of it. So I hope that you can understand it. It's pretty easy. Okay, so now let's try to look at the further notes. Okay, so this is some notes that I want to discuss before we move on for the harder question. Okay, so for instance, so let's try to write down all the force that will apply on this car first. Okay, so normally we have the weight. Okay, then we have the normal reaction. So normally these two forces, we are not going to use it that much because you see it's perpendicular to your motion, except that you are looking at a slanted surface. So if let's say it's a horizontal surface, then when you are talking about the motion, you wouldn't be able to use these two. So we have the driving force of the car that in the direction of the motion, then we have the resistance opposite the motion. Okay, so by looking at this, then we know that for power, then for every instant, the power is equal to the driving force multiplied by the velocity at that instant, right? Then we are going to look at it in the other case as well, which we talk about acceleration. So if we are interested to find out what's the acceleration of the car at that instant, then which means that we need to find the net force. So in this case, it will be the net force is equal to ma. So you can see that the net force of this car is going to be the driving force minus of the air resistance, like all the resistance force lah, like air resistance, friction, and so on, then equal to ma. Okay, so now let's try to imagine we have the situation where the power of the car is always constant, so which means the rate that the car is doing work is always the same, and the resistance of the force X on the car is also a constant. So this car is actually starting from rest until a maximum velocity, and we are going to look at what is the changes for all these variable when this car is accelerating to the maximum velocity. Okay, so the first thing, so we can see that the car start from rest and after that until a velocity of 10. So we assume that in this case, this V is like considered a low one compared to the future two. Like compared to 20 and 30, the velocity of 10 is like a low one. Okay, so when it's at this situation, when the V is low and you imagine if the power of the car is always constant, if V is low, it means that the driving force at that time is actually high. Am I right? Because they multiply with each other one. So if let's say your V decreases, then your D will increases. So if you're having a low V, then you're going to have a high R. So the driving force here is high. Okay, if let's say the driving force at this point is high, then the resistance force is constant, right? So if you have a high D, you minus the resistance, which is constant, then which means your net force is going to be high as well, right? Because you have a big number minus a constant, then you get a net force which is high. So if let's say the net force is high, then meaning the acceleration will be high as well. So in this case, the V actually speeds up quickly. Okay, so now let's see what happened if let's say the car continue to move with the same power, but now the velocity increase until 20 already. So you see, compared to 10, actually V become higher. Am I right? So when your V become higher and we try to look at the equation here, so the car has to still provide the same power. But then when the V is high, then which means on the other side, your driving force will become low. So when the driving force become low, is a lower number is going to minus off with the air resistance, which is still the same. So which means the net force that you have is going to be lower, right, compared to the previous one. So that's why the acceleration that you can generate is always to be lower as well. So if the A low, then which means that V actually speeds up slower. Okay, so actually you can try to understand it in the idea where, when we talk about the power, like how you, it's like how much you press your pedal. So when you start from a lower speed, right, then it's actually easier for you to speed up a car when you try to compare it's already at a high speed and you want to speed up the car. So it's actually something, some kind related as well. Okay, so now let's try to see. If let's say you continue to drive the car with the same power, but your car is accelerating until the V, which is a maximum already. So at this point, you're reaching a maximum velocity. Okay, when your velocity is maximum, what happened to your acceleration? So that's maximum already, right? Which means there's not going to be any change for your V anymore. So the acceleration is zero. So maximum velocity happens when acceleration is zero. So if your acceleration is zero, which means that your net force will be zero as well. If your net force is zero, what does that mean? It means that your driving force is already equal to the resistance. So that's why this car is in equilibrium, and that's why your car is moving with a constant speed, that your A is actually zero, and that's the part for maximum velocity. Okay, so I hope that you can see like the whole relation of how the car works. So please remember that in this situation, we are looking at a constant power of the car. So normally, if let's say you need to find the maximum velocity of the car, right, you need to know what is the maximum power output. Okay, because if you didn't know the maximum power, then you wouldn't be able to know the maximum velocity as well. So you need to know the maximum power output so that you can try to find the maximum speed that the engine can generate. Okay, so now let's look at example 2. Okay, example 2, a car of mass 1500 kg has an engine that has a maximum power output of 200 kilowatts. So the resistance to the motion is typically 5,000 Newton. Okay, so for this question, you are going to look at like three different sub questions, but it's all based on the same question that's given, which is the mass is 1,500 kg, then the maximum power output is 200 kilowatts. Okay, then you have the resistance, which is 5,000. So question one is to find the maximum speed that the car can achieve on a level road. Okay, so in this idea, when you look at the words maximum speed, so if let's say the v is max, it actually tells us that the acceleration will be equals to 0. So if the acceleration is 0, it actually tells us that the net force is equal to 0. If the net force is 0, then we know that the driving force will be equal to the resistance force. Okay, so in this case, the resistance is given 5,000, so we know that the driving force is also 5,000. So that's which the car reaches its maximum speed. So after we get the driving force for 5,000, then now we can try to find out the V maximum. So the maximum power is equal to the driving force multiply the maximum velocity, right? So that's why the maximum power is 200,000, then equal to the driving force, which is 5,000. Then we have V maximum. So in this case, after divide, then we can get that the maximum speed that the car can achieve is actually 40 meter per second. Okay, 40 meter per second is actually quite a lot. Yeah, if you try to look at it like this, then it seems like very slow. So, because around 20 something is already 100 kilometer per hour. So that's why 40 meter per second is actually quite high already. Okay, so now B, find the instantaneous acceleration of the car when the engine is working at its maximum power. Okay, so you say it's a different thing. So when the engine is working at the maximum power, it doesn't mean that the car is driving at a maximum speed, because it can be the driving force or it can be the velocity. So you must make sure that you do not confuse with the idea of maximum speed and the maximum power. So this idea is basically just to tell you that the engine is working at 2,000 kilowatt, just like that. Sorry, 200 kilowatts. Okay, and the car is traveling at 20 meter per second. And the question wants to find out the instantaneous acceleration. So in this case, since we have the power and we have the instant velocity, so for now, then we can try to find what is the driving force. Then we can try to find the instantaneous acceleration, right? So you can see that the words that they are trying to use is very particular. Is it you are getting average or you are getting instantaneous? So that's a different thing that we need to use. Okay, so in this case, then same thing, we can use power is equal to dv, because we are getting what is the driving force at that instant. Then we are going to find out the acceleration by using F equals to ma, right? So that's why the power is 200,000. Okay, equal to, we are going to get what's the driving force at that part. Then the velocity is 20. Okay, so by divide, then we can get the driving force is equal to 10,000 Newton at that part. Okay, so now by having the driving force, then we can try to find out our net force, then equal to ma already. So the driving force minus the resistance will be equal to the mass multiply the acceleration. So 10,000 minus the resistance 5,000 given in the question, then equal to m is 1,500 kg acceleration. Okay, so 1,500 a is equal to 5,000, and solving this, then we can get the acceleration is equal to 3.33 in 3SF meter per second. Alright, let's try to look at these two cases. So for both part A and part B, right, the engine of the car is actually working at its maximum power. But then for part A is maximum power and the speed that actually the car achieved is already maximum. So that's why you can see when you compare to part A and part B, the driving force for part A is generally lower. You can see, right, 5,000 and here is like 10,000. Because when we say the power is the same, if the velocity is high, then which means the driving force is going to be low. If the driving force is going to be low, then that actually makes your force become small. then after that your acceleration will become low. So that's why in this case, when V is the maximum, then your net force becomes zero, and that's why it achieved the highest velocity, then the A becomes zero here. But when you look at part B, so the power is still the same, which is at the maximum, but the car doesn't achieve the maximum velocity yet. So in this case, when the velocity is low, you can see that the driving force is high. So when the driving force is high, what does that mean? Which means that your total net force is going to be high. So that's why you will have a certain acceleration, which is going to be like higher than part A. Okay, so I hope that you can see the connection and to understand that what's the difference when we say that it's maximum velocity and maximum power. They means the different thing. Okay, so now let's look at part C. Find the instantaneous acceleration of the car when the engine is worked at its maximum power as well, which is just now the 200 kilowatts. And the car is traveling at 20 meter per second up a hill, which is inclined at the shift sign is 0.28 to the horizontal. Okay, so you see for this question is actually the same with part B, but it's just that part B is moving on a horizontal surface, then part C is on a slanted plane. Okay, so in this case, it will be easier for us to draw the force diagram, because later when you try to find out the net force, you might need the diagram. Okay, so this is the slanted one. Okay, so you do not really need to know what is the, I mean, you can press the calculator to get the value lah, but I mean, at the end, when you sign this value, it's just going to give you back 0.28. So do not need to do that. So this angle is shift sine 0.28. Okay, then we have the car. Okay, so the car is actually driving up, right? So up a hill, so the car is driving here. So we have the driving force, then resistance opposing the motion, right? After that, there's this weight of the car, which is going to be, just now it's 1500, so it's 15000. Okay, and that's this angle as well, which is the same with this. So normal reaction that do not affect much. Okay, so now when we try to look at this, then the same thing, we can try to find out what's the driving force first. So power equal to D multiplied with V. So power 200,000. So we have the driving force, the velocity that we have is 20 meter per second. So D is equal to 10,000 Newton. Okay, so after we get this, then now we can try to find the net force. Yeah, so as you can see here, so this is the D, so it's in the direction of motion, so that's why D is going to minus off the resistance, and it's going to minus off the resolving part for the weight as well, because it's opposing the motion also. So let me try to write W first. W sine theta. Okay, because the angle is here, right? So you are getting the direction here. Then it will be equal to MA. Okay, so now let's substitute all the value that we have. So 10,000, the resistance is still the same, which is 5,000 Newton. Then minus off the weight. Remember, you are using the weight, yeah? And then sine theta. So we know that it's sine shift. Okay, if you are going to write, then it will be like this. So you realize that you sign a shift sign, then at the end you are still getting 0.28, then equal to the mass multiplied by the acceleration. Okay, so this is how we can get the acceleration. So we can get 1500 A is equal to 5000 minus of, so you get back 0.28, then multiply 15000, and that gives us 4200. Okay, so this is equal to 800. So acceleration is equal to 0.533 meter per second in 3 significant figure. Okay, so yeah, that's how we solve this question. Alright, so now we'll be looking at two past year questions before we end the lesson here. Okay, number three, a car of mass 1,250 kilogram is moving on a straight road. So on the horizontal section of the road, so this car has a constant speed of 32. So the speed is always 32 meter per second. So there's a constant force of 750 resisting the motion. So that's this, then the driving force is towards this direction lah. Okay, So the mass is given by 1250. Okay, so A1, the question wants to find out the power developed by the engine of the car. Okay, so the idea of like putting in this question is to emphasize the word for constant speed. So the idea is the same thing like when it reaches the maximum velocity that the acceleration is A. So I hope that you still remember that when we talk about constant speed, what is that actually mean? So constant speed means that there is no net force, am I right? So you must remember this. So which means the particle or the car here is in equilibrium. So that's why if there is no net force, which means for our part 1 here, the driving force is basically equal to the resistance force, which is going to be 750. Okay, so that's the idea of you need to understand the question so you get the information that you need. Okay, so after we get the driving force, then everything become easier already because you see that's like just 2 marks question. So power is equal to the D, okay, multiplied by the velocity. Again, I want to emphasize why can we use the V here? Because this question didn't want us to find out the power in the instant. But the idea is this car is having a constant speed. So that's why the power will be constant as well. So that's why you can use distance multiply the, so you can use the driving force multiply the velocity. Okay, so it's equal to 750 multiplied by the constant velocity, which is 32. Okay, so from here, then you'll be able to get 2400 watts, which if you want to change it to kilowatts, then it will be 24 kilowatts. Okay, so that's the part for part 1. Okay, part 2, given that this power is suddenly decreased by 8 kilowatts, find the instantaneous deceleration of the car. Okay, so what happened is at a certain instant, the power suddenly decreased by 8 kilowatts. So which means what is the current power now? So previously, the power is always 24000. Am I right? So because the car is keep on traveling with a constant speed of 32 meter per second, so which means in this case, when the power suddenly decreases by 8 kilowatts, then how do you get the new power? Is going to be equal to the power at the constant power minus of 8,000. So from there, we can get 16,000. Okay, so by having this, now we can try to find out the driving force because the question tells us that the power suddenly decreased by 8 kilowatts, but the constant speed is still the constant there because we are getting at that instant, right? So P is equal to dV. So we want to find out what's the driving force at that instant when the power suddenly decreases by 8 kilowatts. So it's 16,000 equal to the driving force and the V here is 32. Okay, then we can get the driving force at that instant is actually equal to 500 Newton. Okay, yeah, so that's the idea of it. Yeah, so I hope that you do not get the idea where when the power suddenly decrease, it means that the speed decrease, okay? Because this thing like happen at that instant, it wouldn't be like suddenly, how do you drive a car at 32 meter per second, then suddenly even you try to like put a braking force, then it's still going to be like a certain time interval. So that's why in this case, it's like the change is actually in the driving force. So the driving force change. So that's why later you will see that there will be a deceleration happen that cause your V to decrease. But the instantaneous deceleration makes the V decreases. It's not happen at that instant when the power suddenly decrease. Okay, so yeah, that's the idea. So now we can continue. So D minus resistance is equal to MA. So you can get 500 minus the resistance here, 750, equal to the mass, which is, what's the mass given here? 1250 and acceleration. Okay, so you can get 1250A is actually equal to negative 250. So you can get A is a negative value. So that is correct because the question already tells us it's deceleration. And you can understand when the power suddenly decrease, then it cannot be like acceleration lah, right? Okay, so in this case, then which means the deceleration, remember to change it to positive, yeah? So deceleration is equal to 0.2 meter per second square. Yeah, sorry, I hope that the space isn't like too small for you to write because I want to fit this question into like one page. Okay, now let's look at part B. On a section of the road inclined at shift sine 0.096, so this is similar with the previous question, so do not really need to change it in your calculator, just keep the value. So the resistance to the motion of the car is 1000 plus 8 V Newton when the speed of the car is V meter per second. Okay, so same thing, we can try to draw out the diagram. Okay, so just keep the value. Okay, so the car is here and it's still moving up, right? So travel up, so that's why the driving force is still going up, then resistance going down. Okay, then we have the weight of the car, which is 12500. Okay, then the angle. Okay, so yeah, the normal reaction, we doesn't really need that, so it's okay for not to write that. Okay, so now you see the question is still the same where is the constant speed. So that's why for constant speed, again, the net force will be equal to zero. Okay, so the net force is equal to zero. So in this case, then you need to do some resolving. So when you try to resolve it in this direction, okay, resolve it in the direction of the plane, then we can get the driving force will be equal to the resistance and then plus the weight sine theta, right? Okay, so now the driving force is what we want to find. So resistance is given 1000 plus 8V, and then in this case, our W here is 12500. So you know, after you sign this value, it's going to give you back the decimal. So 0.096. Okay, so let's do some calculation. So it's going to be 1200 and plus 1000 plus 8V. So that is 8V plus 2200. So after we get the driving force, then now we can try to use the formula of power to help us to do that. Okay, because this is a constant speed as well. So that's why you can use the constant power will be equal to the driving force then multiplied by the constant speed. Okay, so our power here is equal to, I think it's given, yeah. So the engine is working at 60 kilowatts, then equal to the driving force is 8V plus 2200 multiply V. Okay, so now we can continue to solve this. So 8V square plus 2200V is minus 0.60000 equals to 0. Okay, then when we continue, we can divide by 8 if you need. Okay, so factorization, then you will get two answer, but you know that in this case there's no change in direction, right? So that's why, let me try it right here. So your V is supposed to be a positive number, so that's why V is equal to 25 meter per second. Okay, so that's how this question works. Okay, so now let's look at the last example before we end. Okay, number four, a car has a mass of 1000 kg, so the mass is 1000. Then when the car is traveling at a steady speed of V, then the V is greater than 2 and the resistance to the motion is equal to AV plus B Newton, okay, where the A and the B is constant. So you can actually roughly know that find A and B, which means that you will be given like two situations, then you need to use two simultaneous equations to help you to solve this problem. So let's try to look at the first one first. So the car can travel along a horizontal road. So the horizontal road at a steady speed of 18. So this is the car. Then the speed is steady at 18. V steady. So which means it's like constant velocity in other words. So the engine is working at 36 kilowatts. So the power is equal to 36,000. Okay, so now let's try to solve the first one first. Try to get the equation for the first one. So if let's say the car is in this direction, then which means it's going to be driving force and also the resistance force. Okay, So given that the velocity is constant at 18, so which means that if V is steady, which means our net force is going to be 0. So if the net force is 0, then which means the driving force is equal to the resistance. So in this case, we are given that the resistance is AV plus B, right? So we have the V as well. So that's why in the first case, our resistance is equals to 18A plus B. Okay, just substitute the position of V by 18 because the driving force is equal to the resistance. So which means, sorry, I should write D here because we do not need the resistance. Okay, so the driving force equal to the resistance. So that's why the driving force is equals to 18A plus B. Okay, so after we get this, then we can try to use the formula of power to help us to do this because this is a steady velocity, right? Then we can get the average power as well. So the power will be equal to D times V. So it's given the power of the engine, which is 36,000, then equal to the D that we found, 18A plus B. So the velocity is 18. Okay, so let's expand it. So 36,000 divided by 18, we have 2,000. So it's 18A plus B equal to 2,000. Okay, and that gives us the first equation. Okay, so now let's move on to the second part. So we have the car travel up a hill at an angle of theta to the horizontal. So we can try to draw it out. Okay, so that's the here. So it's given that the sine theta is equal to 0.05. Okay, so the theta is here. So the same thing, we try to draw a car. So this car is traveling up as well. So travel up a hill. So the engine is working at 21 kilowatt. The steady speed is 12. Okay, so that's why the V is steady at 21. Say 21, oh sorry, my fault, so 12. Okay, and then the power is 21 kilowatts, so 21,000. Okay, so after we got this, then now we can try to same thing, we need to do our resolving here because the velocity is steady, right? So which means the net force is equal to 0, so we need to balance up the force. Okay, so we have the weight, so this is going to be theta as well, the driving force and the resistance. Okay, so the driving force will be equal to the resistance plus the weight sine theta. Okay, so the resistance is A, so the same thing here, AV plus B, and our V here is 12. So that's why it's 12A plus B. So the weight is going to be 1,000. So 1,000, 10,000 for the weight. Okay, then after that, the sine theta 0.05 given. Okay, so now just simplify this, then we can get D will be equal to 12A and then plus B plus 500. Okay, so this is not the end yet. Yeah, so you still remember we need to use the driving force to get the power. Then only we left with the two variable, which is A and B, right? So the power in this case is 21000 equal to the driving force, and then plus 500. Okay, multiply the V in this case is 12. Okay, so same thing. After you expand and rearrange everything, then we can get 12A plus B is equal to 1,250. Okay, 21000 divided by 12, then minus of 500. Then this is how we get the second equation. So now we have two equations, then we can solve them simultaneously. So the first one minus the second one, then we can get 6A will be equal to 750. So that gives us that A is equal to 125. So the second one depends on you which one you want to use. So B will be equal to 1250 minus 12 times A, 125. So from here, then we are able to get our B, which is equals to negative 250. Okay, so just like that, need to just understand the question, then you form your equation, then you should be able to solve that. So I guess for the power part, it's actually not too difficult as long as you can understand the for the idea for average, constant speed, instantaneous is basically by using the thing that you learn in power and also the knowledge, the prior knowledge that you have in Newton's second law of motion, then you solve it. Okay, so that's pretty much the last lesson for this syllabus already. So after this, you can start your revision for M1. So that's pretty much for today's lesson. Thank you.